KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we are going to focus on Doppler effect. Okay, ma? Right. In our last class, we discussed refraction at a rarer medium. When a light wave meets the the surface which separates rarer medium and denser medium, but here the light ray is entering from denser medium to rarer medium. Denser medium to rarer medium. Okay, then it bends away from the normal. So that there we discussed how it satisfies the laws of refraction. Then afterwards we came to discuss reflection of a plane wave by a plane surface. Okay. Afterwards we also discussed when a plane wavefront is passing through a prism, convex lens and a concave mirror, how the reflected wavefront will be. How the reflected wavefront will be either reflected or transmitted, whatever it may be. Okay, right. So this and all we discussed in our last class, ma. Now in this class our focus is the Doppler effect. The Doppler effect. Okay, right. So first of all, what is Doppler is the name of the scientist. So first of all we have to understand what is meant by Doppler effect. What is meant by Doppler effect. Okay, right. So when we are going to observe a source of light, whether it is natural or artificial, when we are observing the source of light, then we may talk about the frequency of light. We may talk about the frequency of light. Okay, right. Suppose you are moving away from the source. When you are moving towards the source, suppose if the source is also in motion along with you, either in the same direction or in the opposite direction, right? So in all these cases, what about the frequency of light you are receiving? Okay, right. So please try to understand what I am saying. Now here itself I am explaining first of all what is meant by Doppler effect. What is meant by Doppler effect? Okay, right. So there is a source of light, there is an observer. In this case of source of light or in the case of observer, both may be at rest, both may be in motion. Otherwise, one is at rest, source is at rest, the observer is moving towards the source, or the observer is moving away from the source. Otherwise, the observer is at rest and the source is moving towards the observer, or the source is moving away from the observer. Right? Afterwards, both the source and observer may be moving in one direction, or both the source and observer may be moving in another direction, opposite direction when compared to the previous. So finally what I am saying is, when there is a relative motion between the source and observer, what happens to the frequency of the light observed by the observer? What happens to the frequency of the light observed by the observer? The conclusion is there is a change. There is a change, right? See here. When the source moves away from the observer, the frequency as measured by the source, the frequency as measured by the source will be smaller, So see here once again, when the source moves away from the observer, the frequency as measured by the source will be smaller. So what he is saying? So actually, what is the frequency of source? What is the frequency of source of light will be different, and whatever the frequency the observer is experiencing, the observer is measuring, will be different. So here it is smaller. This is the one of the case. That is what source is moving away from the observer. The frequency as measured by the source will be smaller, right? So this is known as the Doppler effect, right? So Doppler effect. So the famous scientist Doppler, who observed the change in frequency, when the observer is changing his position with respect to the source of light. This phenomena is called as Doppler effect. So whether the observed frequency will be decreased or increased or no change, that and all will be special cases. But the primary thing, what is the Doppler effect in case of wave picture of light means, when there is a relative motion between the source and observer, the apparent frequency, that is the frequency measured by the observer, will be different when compared to the actual frequency. Okay, right. Now we will come to the point one by one. See here. If the source is moving, one should be careful in constructing the wavefronts. For example, if there is no medium and the source moves away from the observer, then the latter wavefronts have to travel a great distance to reach the observer. This is the fact. So what he is saying here is a fact. For example, if there is no medium and the source moves away from the observer, then latter wavefronts have to travel a greater distance to reach the observer, and hence take a longer time. You know very well, speed is equal to distance by time now. So when the wavefronts has to travel a greater distance, automatically required a greater amount of time or longer time or more time. Okay, right. Next, the time taken between the arrival of two successive wavefronts is hence longer at the observer than it is at the source, right? See here, the time taken between the arrival of two successive wavefronts is hence longer at the observer than it is at the source. Next, thus, when the source moves away from the observer, the frequency as measured by the source will be smaller. The frequency or the source moves away from the, when the source moves away from the observer, the frequency as measured by the source will be smaller. This is known as Doppler effect, right? So in our space, astronomy, see here, astronomers call the increase in wavelength due to the Doppler effect as red shift. So is one of the important definition but observation, it is also one of the observation. Astronomers call the increase in wavelength due to Doppler effect as red shift, since a wavelength in the middle of the visible region of the spectrum, right? Okay. And one more thing is here itself. So we just I told you what is meant by red shift. Okay. At the same time, we also need to remember when waves are when a wavelength is going to increase due to the with respect to the Doppler effect, which is simply said to be as red shift. Okay. So there itself we also keep in mind wavelength in the middle of the visible region of the spectrum moves towards the red end of the spectrum. Moves towards the red end of the spectrum. Okay, right. Moves towards the red end of the spectrum, and when the waves are received from a source moving towards the observer, when the waves are received from a source moving towards the observer, there is an apparent decrease in wavelength. This is referred to as blue shift. Okay, right. So from the starting of this class, I want to highlight what is Doppler effect, what is red shift, and what is blue shift, right? So as simple as such, this definition is not there on the board, but you have to remember. I am saying as simple as such. Okay, so when there is a relative motion between the source and observer, the apparent frequency is different from actual frequency. The apparent frequency of light is different from actual frequency of light. This phenomena is called as Doppler effect. Doppler effect. Otherwise, you can also say that Doppler effect of light. Okay, right. Afterwards, there is increase in wavelength due to the Doppler effect, which is simply called as red shift. Why? Because the wavelength is in the middle of the visible region of the spectrum. Moves towards the red end of the spectrum. So whatever the wavelength which is present in the middle of the visible region of the spectrum moves towards the red end of the spectrum. That's why it is called as red shift. Okay. At the same time, in some other aspect, when waves are received from a source moving towards the observer, there is an apparent decrease in wavelength. This is called as blue shift. Okay, right? So afterwards, after completion of this, so what is Doppler effect, and what is red shift, and what is blue shift? Okay, right. So as we discussed in our that is what is Doppler effect, which is not only for light, which is also for sound waves, that we discussed in our first year syllabus, last chapter, waves. There we discussed what is the Doppler effect of sound waves. Okay, right. And one more small assumption here, small and important assumption is, for velocities small compared to the speed of light, we can use the same formula which we use for sound waves. I will repeat once again. For velocities small compared to the speed of light, we can use the same formula which we use for sound waves. Okay, right. Next, the fractional change in the frequency. What is the fractional change in the frequency? Delta nu by nu, change in frequency, the ratio of change in frequency to the original frequency. The ratio of change in frequency to the original frequency is simply called as fractional change in the frequency, right? Is given by minus nu radial by c, where nu radial is the component of the source velocity along the line joining the observer to the source relative to the observer, right? So I will repeat once again, I don't want to confuse you, but I want to give clarity, right? So what is apparent change in frequency? What is the fractional change in the frequency? Means mathematically it is delta nu by nu. Ratio of change in frequency to the original frequency is simply called as fractional change in frequency, right? Next, first let me explain what is nu radial. What is nu or v radial, because here we are using v to represent the symbol, right? So has v right? V radial, that is what V radial is the here component of the source velocity. V radial is the component of the source velocity along the line joining the observer to the source relative to the observer, right? So please keep in mind what is delta V by V and what is V radial. C is the speed of light, it's okay, C is the speed of light, because why I am asking you to remember means based on that the formula will be, okay, right? Then you will come to know what is the formula to measure Doppler shift, okay, right? So now itself I am explaining the terms which are present in Doppler shift. So one term or one word is delta nu by nu, it is a fractional change in frequency. Afterwards V radial is the component of the source velocity along the line joining the observer to the source relative to the observer, okay. Afterwards V radial is considered positive when the source moves away from the observer. Remember, V radial is considered as positive when the source moves away from the observer, okay, right? So that the Doppler effect can be expressed, see here it is the formula to so with that you can express Doppler shift. So delta nu by nu means frequency, V is the speed, delta nu by nu is equal to minus V radial by C. So this is the formula, with that you can measure Doppler shift, okay, right? So if you go for the validity of this formula, that is what, when the speed of the source is small compared to that of light. So remember one thing, when the speed of source is small when compared to the speed of light, then this formula has validity. And more accurate formula for the Doppler effect is valid even when the speeds are close to that of light, but requires the use of Einstein's special theory of relativity. Requires the usage of Einstein's special theory of relativity, right? So the Doppler effect for light is very important in astronomy because it is on the basis of the measurements of radial velocities of distant galaxies, okay. So what are the things we are doing with respect to astronomy, and what is the use we are getting to our daily life, okay, and to increase the standard of daily life, etc., that we know, okay, right? Now I am going to explain you one example problem based on this information. So you please be concentrate. See here, what speed should a galaxy move with respect to us so that the sodium line at 589 nanometer is observed at 589.6 nanometers, okay? At with what speed should a galaxy move with respect to us so that the sodium line at 589 nanometers is observed at 589.6 nanometers, so that the way there is a change in wavelength now. So to get this much of change in wavelength, what is the speed with which galaxy has to move, right? So the formula is same, delta V by V is equal to minus delta lambda by lambda, that you know from this formula. C is equal to nu lambda, and for small changes in nu and lambda, nu means frequency, lambda is the wavelength, right? So mathematically we found delta lambda, it will be plus 0.6 nanometers. Then by using this formula you can find out that V radial is equal to, see this calculation, taking this C to this side, and so that V radial is equal to 306 kilometer per second. V radial is equal to 306 kilometers per second. So the galaxy is moving away from us. Based on the sign convention, you can say that galaxy is moving away from us. When the galaxy is moving with 306 kilometers per second away from us, then there will be change in wavelength of this much, that is what 0.6 nanometers, right? Now another example problem, right? I didn't write on the board, but I will explain you. So please keep textbook with you, is a theoretical example. See here, first one, when monochromatic light is incident on a surface separating two media, full stop, okay, comma, the reflected and refracted light both have the same frequency as the incident frequency. I will repeat once again. When monochromatic light is incident on a surface separating two media, comma, the reflected and refracted light both have the same frequency as the incident frequency. Explain why. Okay, so come to the point of explanation. Reflection and refraction arises through the interaction of incident light to the atomic constituents of matter, right? So surface, atoms. So surface means, okay, it is the top one and there is a matter, so there are atoms, right? So when the incident light is interacting with atomic constituents of matter, right, then atoms may be viewed as oscillators. So oscillating, the atoms are oscillating means whatever it may be, when the particle is oscillating means there is some frequency, right? So when the atoms are viewed as oscillators which take up the frequency of the external agency, that is light, then it causes forced oscillations. Then the frequency of the light emitted by a charged oscillator equals its frequency of oscillation. Thus the frequency of scattered light equals the frequency of incident light. I will repeat once again. The question we understood, but if you go for the solution, whenever the incident light meets the atoms or the oscillating atoms, when incident light meets with the oscillating atoms takes up the frequency of the incident light, causing forced oscillations, right? Then the frequency of light emitted by a charged oscillator equals the frequency of oscillations, so that the frequency of scattered light equals the frequency of incident light. Frequency of scattered light equals the frequency of incident light. Okay, ma? Right. Next one, when light travels from a rarer medium to denser medium, the speed decreases. Does the reduction in speed imply a reduction in the energy carried by the light wave? No. The answer will be no, because energy depends upon the amplitude, not the speed of wave propagation. Next, C. In the wave picture of light, intensity of light is determined by the square of the amplitude of the wave. Right. Full stop. What determines the intensity of light in the photon picture of light? What determines by the intensity of light in the photon picture of light, right? Okay. Here the answer is, for a given frequency, intensity of light in the photon picture is determined by the number of photons crossing an unit area per unit time. So in that chapter, dual nature of radiation and matter, we came to know this point. So in case of photon picture of light, the intensity of light is determined by the number of photons crossing an unit area per unit time, okay, right. So that is about this class, ma. In this class we focused to learn what is Doppler effect, what is redshift and what is blue shift, what is the formula to calculate Doppler shift. Then two example problems we discussed, example 10.1 and example 10.2, okay, right. So whenever there is a relative motion between the observer and source of light, the apparent frequency is different from actual frequency. This phenomena is called as Doppler effect of light, okay. At the same time, based on the relative motion, sometimes there is increase in wavelength, sometimes there is decrease in wavelength. In case of increase in wavelength due to the Doppler effect, the wavelength in the middle region of the visible spectrum moves towards the red end of the spectrum. Then it is called as redshift. At the same time, when waves are received from a source moving towards the observer, there is an apparent decrease in wavelength. This is called as blue shift, and this is the formula to measure Doppler shift. Okay, so afterwards, you know very well, we discussed example 10.1. There, to get the change in wavelength of 0.6 nanometers, it has to travel, the galaxy has to move with 306 kilometers per second away from us. After that, in second example, we discussed 3 different points. Okay, so in the first point, why the frequency is same in case of reflection and refraction for the light wave. Afterwards, why what is the relation between intensity, what is the relation between frequency and amplitude, right? So frequency no change, frequency no change. Okay, sorry Amma, he is asking the relation between, that is what, energy and frequency. There is no relation, energy relates amplitude. Okay, afterwards, regarding the photon picture of light, number of photons crossing an unit area is determined the intensity of light. Okay, we will continue in the next class.